What's up YouTube and welcome back to In the Shop TV. So the last time I saw you guys, we were working on putting a new set of Holley two-piece valve covers on our LS engine. They came out super great, and then we did put this ICT billet valley pan cover on here. What I haven't showed you off camera is that we took the water pump, our original old water pump, which was in good shape, was actually fairly new, cleaned it up and painted it, and we got a new oil pump installed, something I feel like you should do if you're gonna refresh a motor. There's a trick I wanna show you guys with that. A lot of people can struggle, especially if you have an LS engine that's actually in a vehicle and you wanna change the oil pump. The engineers at GM did some wonky stuff when they came up with that. So I'm gonna show you a quick trick that'll make your life a lot easier if you ever have to change one of these in a vehicle. So now that we got all that done, what I'd like to get done today is change this timing cover. Since it's gross and ugly, it needs to be replaced. We're gonna have to scrape the gasket surface and clean it. So we have a nice clean surface to mount up our new one. We're gonna reinstall the water pump that we fixed up, and we're gonna get our crank pulley, our harmonic balancer reinstalled. All right, let's get started. All right, so this is our new Melling oil pump that we installed. It's the model M295. It is the standard flow. This is not a high performance build. It's just got the standard, the stock rotating assembly and cam in it. So this is just to freshen up of the engine. It's got low miles and I don't really want to get into the internals of it. So we're going with the standard flow oil pump. Before we get into the trick with installing that, I want to take a second to explain what this is right here to you guys, because a lot of you guys don't have this on your LS engines. This is called VVT, or variable valve timing. You might notice on your timing cover that there is no metal piece screwed to the top portion of it. On VVT timing covers such as mine, you'll notice that it has a circular metal device screwed to the front of it with a little wiring harness that gets plugged into there. There's an actuator on that. Better if I just show you guys. This is the little cover I was talking about. Inside here is an actuator that controls the variable valve timing. So what is variable valve timing? Why am I leaving it on my engine? And why do a lot of hot rod guys delete it and get rid of it? The quick version is VVT is a system that automatically adjusts valve timing. So the computer, or ECU, will sense your engine load, and it also monitors the camshaft through your cam position sensor. It uses that VVT data to determine the best valve timing for your current driving conditions. It then sends a signal to that funny little cover on the timing cover that I showed you, and that controls oil flow through a special bolt on the camshaft itself. So that solenoid or actuator will use oil control or oil flow to change the direction one way or another, the rotation rather, of that solenoid to advance or retard the cam timing basically. So it's actually a pretty good system that GM came up with. It doesn't have a lot of problems, and you kind of get the best of both worlds. So you get a nice smooth idle and low end torque, and it could also retard your cam timing, or your valve timing, excuse me, at the top end to get a little more power. So that all sounds great. Why in the world do people delete it? Well, I'm not deleting it, but the reason why a lot of people do is because your cam selection is extremely limited. Right, so when everyone decides to do an engine, the first thing on their mind is, I'm gonna throw a big camshaft in there, right? Everyone wants a big camshaft, or one that has a low LSA, lobe separation angle, so they get that nice lumpy idle and choppy sound and all that good stuff. That's all cool, that's great. It's great if you put a big cam in your engine, but you have very, very few choices of cams that are VVT cams for this engine. So therefore, if a guy wants a really high lift or something, or a special lobe separation angle on his LS build, he's got to ditch the whole VVT system, because the VVT cams that are available just probably don't work for his desired needs. It's not because the system sucks or it wasn't designed well. It's actually really good. And if you are building an engine or a vehicle or whatever for daily driving use, or you're not going to be on a strip or anything like that, or maybe just once in a while you go down to the drag strip and do a little bit of tire burning and racing and whatnot, VVT is going to be just fine for you, especially on the streets. It's going to be fine because, like I said, it's going to give you that beneficial performance down low and up high. It's just that if you want to change a cam and do a more radical camshaft or a very specific cam profile, there's not a lot available. That's why they delete it. If you are someone who wants to do that and delete variable valve timing, at bare minimum, what you're going to need is a non-VVT camshaft, a new timing cover, and I believe obviously that special cam bolt that we talked about has to be replaced. Oh, and you'll also change this funny looking thing here. You're going to change to a timing gear and new timing chain, obviously, if you're getting that far into it. That is a non-VVT timing gear. All right, oil pump change, special hack, special tip and trick. Right here is the pickup tube for our oil pump that goes back to the sump of the pan. I did not bolt it in because I'm changing the oil pan, and once I turn the engine upside down, I'll have a much better access to all that. I'll be able to clean up and take care of some stuff. It's just kind of perched in there for right now. But if you ever have to change your oil pump on an engine that's in the car, it could prove to be extremely challenging. For one, you've got all the accessories and stuff on the front of the engine, your water pump and your belts and your compressor and your alternator and the brackets, timing cover, et cetera, et cetera, et cetera. The list goes on and on. Plus, you're in very tight quarters in the front of a car. And then you get your timing cover off, and this is what you see. And you go to unbolt the pickup tube, and the geniuses at GM Engineering, their pickup tube has one bolt, even though the oil pumps have 2 bolt holes on them. And they decided to use the one that's all the way back there that you can't possibly fit a wrench into and get to it at all. So now you've got your whole front of the engine ripped apart. You're ready to change this thing and you can't get that bolt out. So maybe you got to take the oil pan off now to get to it. So, you know, now you're getting under the car and you're dropping an oil pan and everything that's in the way, and it's just a very, very costly and time-consuming procedure. There's a way around that, though. All you need to do is take the bolts out, not fully, but somewhat out of the oil pan, and drop it about an inch or so. Once you get that drop of about an inch, you have all the room you need to be able to get your fingers and a wrench in there and take that one bolt out of the oil pump. The tube will come right out and you're able to pull the pump right off. So there's your pro tip for the day. Hopefully you're not already at the point where you're flinging tools all over the place and using some very choice language, amongst other things. Not that I know anything about that. All right, enough of Mike's half-ass engine academy of learning today. I'm gonna get back to work on my engine. First thing we're gonna do is we're gonna work on this gasket surface over here because it's kind of cruddy and dirty, and we gotta get it cleaned up as best we can for our new timing cover. All right, so we have a new gasket here for our timing cover. We went ahead and purchased a new set of ARP bolts. And of course, we have our new timing cover as well. All right, so our timing cover is loosely placed and our bolts are just barely even started. They're just kind of like halfway in. This is a really important step that I think a lot of people overlook. When you start this, it needs to stay loose and so that you can move it around. The reason for that is you have to align. See, this front seal doesn't sit tight to the crank snout. It sits tight to the actual crank pulley or the harmonic balancer that's on here. So if you go ahead and just tighten this up where you think it should be, because that's where the bolts are, yeah, it might be, you know, a couple thousandths of an inch off on your seal for your harmonic balancer, and you can wind up with a front main seal leak. So you got to leave this loose, and then there's 2 ways of lining it up, and I'll show that to you now. All right, so this is one way. This is what's called an alignment tool. You can just slip this on, and what it does is it'll self-center with that front seal. Make sure your front seal is dry. I've heard a lot of people say you should lube it up, but you really don't want to lube these up at all. You want to leave them nice and dry. So you'll center that up, and you'll see some resistance right about there. And once you push it in, the timing cover moves just a tiny bit, and now it is centered to this alignment tool. This alignment tool is made to the same size and spec as your harmonic balancer, so it's just kind of taking the place of that, so you don't have the big balancer in the way while you're doing this. If you don't have this tool, that's fine. You don't need it. You can use your harmonic balancer. Just remember to keep this loose and get your harmonic balancer centered up and installed. Not screwed in, obviously not bolted in, but just kind of placed in there. And it'll do the same exact thing. It'll just line up that front seal with the balancer itself. So this is my procedure for tightening up or torquing the bolts down and getting the timing cover on right. I don't know if this is GM spec. This is the way I do it. So this is my disclaimer. Don't sue me if you get an oil leak. This is what works for me, and I haven't had oil leaks doing it this way. Get yourself your torque wrench ready, and the first thing I do is I go and I get the bottom 2 bolts of the timing cover torqued to 106 inch-pounds first. And that gives me that kind of flat plane across the bottom of the engine block, and make sure that my timing cover is right on that level with that alignment tool in, or your harmonic balance or whatever. So let's go ahead and snug up these 2 bottom bolts. All right, so after we've tightened those 2 down to 106 inch-pounds on the bottom, we're gonna go around, and these should all be finger tight by now or snugged up, and we're gonna torque those down to 18 foot-pounds each. Okay, apologize for the rain noise. So I didn't film most of that because you wouldn't have been able to hear what I'm saying, but it just started to calm down now. I went ahead and torqued these all down to 18 foot-pounds, and I did it in a crisscross pattern, meaning starting here, moving to there, then moving here, starting to here. You get the idea, and so on and so forth. After I did that, I then loosened these 2 bottom bolts again and made sure I went around and retorqued all these just in case it pulled out at all, and then torqued them back down to spec. And I'm leaving these loose for right now because it's on the right plane, and I'm going to wind up changing my oil pan soon. So that's my procedure for doing this. I'm going to go ahead and get the crank snout on now. All right, so the crank or the harmonic balancer, I just kind of go ahead and get that into position. Then I've got one of these nifty install tools, which makes this job a lot easier. It's basically just a long threaded rod that you'll stick inside the crank snout, threaded in there. It's got a thrust bearing on it, which makes turning it easier, and then these 2 kind of heavy duty washers here. So the idea behind this is that you'll get this threaded all the way in until it bottoms out, and by doing that you're creating static pressure on the threads and not using the actual bolt itself to pull the pulley on, because then you're placing a lot of pressure on several threads instead of all of the threads, and you can wind up really messing up the threads on the bolt, or even worse, on the crank snout itself. So I kind of like these tools for that purpose. And very inexpensive, and even if you don't want to buy one, you can go down to your local AutoZone or O'Reilly's or anything, and they will rent you this tool for a nominal fee, which you will then get back once you bring the tool back to them. So kind of no excuse not to do that, in my opinion. So what we do then is we'll grab the end of the bolt on the tool, and then we'll use the wrench to tighten down on this larger nut here, pulling the harmonic balancer on to the crank snout. Okay, so our pulley or harmonic balancer is fully seated. We've ensured that there's a good spacing all around, and we're just going to go ahead and remove the tool from the crank snout. So we just ran our bolt in. What we do is we get a new OEM GM bolt. ARP makes a good one that's reusable. The GM ones are not, because they're what's called torque to yield, meaning the threads will stretch somewhat. And the reason for that is that when the threads stretch, this sucker is not coming off. There is an approved method by GM in order to torque this on. Admittedly, I did not follow that spec. So I don't know if you should take my advice on how to put this on or not, but we did, and we're fine with it. I used the Mega Milwaukee here, and I just did a bunch of short bursts to get it to the point where it doesn't rotate anymore. Gave it a couple more short little wraps, and it's still not turning. So that sucker's on there. It's seated, in my opinion. I don't think it's going anywhere. That is not the approved method for doing this. So follow my advice, don't follow my advice, but my disclaimer is, that's my disclaimer. This is just what I do. You don't have to follow what I do. All right, so we're gonna get our water pump on next. I went ahead and cleaned up these surfaces as best I can, and I can't get them any cleaner than how they look right now, and I feel confident that they're pretty smooth and ready for the new gaskets. So I'm gonna go ahead and get these shop towels that I have plugged in here and the holes out, because I've been known to leave things in before and then have to go back and take everything out after the fact. So always make sure you unplug your hose before you start bolting your new accessories up. Okay, so the water pump can be a little bit challenging. It's kind of nice to have an extra set of hands, but if you don't, you're by yourself, What I did was I held the water pump upside down in my lap, put the gasket on the back of the water pump and got one bolt through, brought the whole thing up to the block and just got this one bolt started. So now we have a gap on this side for us to slip our gasket in and get another bolt started on that side. All right, so we got that one started and this one started. I'm gonna go ahead and run my other bolts in. Hopefully they line up with that gasket. All right, so I couldn't show you with one hand, but I just stick a little bit of a pick in here and you're able to hold that gasket up in place because it kind of drops down and blocks the rest of the bolt hole. So if you just lift up on it a tiny little bit, you can get your other bolts in there. Now that the two top ones are in, with any luck, we should thread right in there. There we go. Gotta lift up on the pump a little bit. All right, so we've got all 6 of our water pump bolts started in the hole. What we're gonna do now is we're gonna get them finger tight, but what I like to do is just kind of lift up on the bottom of the water pump so that the bolts aren't, or the water pump's not riding on the threads of the bolts as you're screwing them in. Just makes things a little bit easier. You don't gall up the threads at all. Torque specs on this supposedly are the first pass, meaning the first go around, is 11 foot-pounds, and your final pass, your final torque down is supposed to be 22 foot-pounds torque. So let's go get started and get these torqued in. All right, so that's our first pass. Now we're gonna go to 22 foot-pounds. All right, that's our water pump. All right, guys, I'm pretty pleased with how things are turning out. I think it looks pretty good, and I'm happy with the installation so far. That's gonna wrap up today's video. Come on back, we've got a lot of stuff to do on this engine. I'm not sure what we're gonna do next. We gotta get an intake, we gotta get our set-switch alternator, compressor, do brackets to hang them all, win the lotto, to afford it all types of stuff. So anyway, hope you guys like this. I hope you enjoyed the little tip about the oil pump. If you're replacing your oil pump, God have mercy on your soul, if it's in the car anyway. And thanks for watching, guys. I'd love to hear your comments, criticism, concerns, anything you got, leave them in the comments. Catch you in the next video. Thanks. I know, I'm a pack rat. I save everything. What can I say? So we can get a nice new clean surface. So we have a nice new clean surface to match up. So we have a great, yeah, if I could talk today, that'd be great. See ya!